And I'm live. That is pretty cool. Today is 6th of April 2026, Monday. And with that, let's just start our contest. No time to die. Yep. This one, Division 4, there are G problems 1, 2, 3, 4, 7 in total. This is Division 4. So I am expecting that this is not going to be too difficult, and it would be very, very cool if we can solve all of these problems. Let's see. If we can, that would be very cool. Like actually pretty cool. So competitive programming, start new Vim. Why is there always an update in Lua snip? And what does Lua snip even do? It gives completion like LSP. Okay, cool. Pattern not found. Nix. Who? Okay, cool. This 38. Let's start at 40. Cool. 1 minute. Some seconds. Yo, stop this. Cool. 1 minute 40 seconds for the contest to begin. As good programmers. Good. Contest is about to begin. And we are using NewVim version 0.12. Shit. So this means that version 1 of NewVim is also not out, which is pretty crazy. And what is this? Help poor children in Uganda? Help Kuwasa? Charity where you can use and copy it. Shit, that is pretty crazy. I never saw that. Okay, 50 seconds. 50 seconds for the contest to begin. Division 4. Yep, Division 4. 40 seconds to go. And if we can solve all the problems in this contest, it would be pretty cool. And the first few problems are going to be very, very easy. Like, actually very, very easy. Okay. It is just a virtual contest, but still we will give it as if we are in an actual contest. Ooh, let's go. Okay. Welcome to the Magnus is given an integer x. Your task is to choose an integer y such that the value of minimum x and y is maximized. If there are multiple valid y's, you may output any of them. For each test case, output minimum of x and y is maximized. Okay. Oh, shit. We'll submit this. Okay. And I hope this works. We are just outputting the same number that we are getting because yes, if you go higher, then you will get x, and if you go lower, you will get the lower number. And your task is to maximize. And I hope it works. Okay, it does work. Now you are given 7 integers, a to 7. You must negate 6 out of 7. Why is the enacting a meme? 7 integers. Okay, you must negate 6 out of the 7 numbers. That is, multiply them by -1 overall over all possible ways to negate 6 out of 7 integers. Find the maximum possible sum of a maximum possible sum of a. 41 into 5 would be 205. Just take the smallest numbers and negate them. uh, Vector integer a size 7 for int reference x in a, take into x and sort ranges, sort a, and answer this equals 0 for int I equals 0, I smaller than 7, I plus plus res minus equals a I till 6 and res plus equals a 6 c out res. This should also work. We are not going to test it, we are just submitting it, and hopefully it works. Hopefully it did work. Let's move on to the next problem. Okay, good, it worked. Next one. Problem number C. You are given an integer n and you must construct a permutation of length 3n such that if you partition the permutation into n contiguous blocks with 3 elements, the sum of the median of these blocks is maximized. Okay, a permutation of length 3n. More formally, sum of the median is maximized. Sum of the median is maximized, and we have been given n and we have to output. Okay. Here answer should be 2. Sum of the median, okay, they can be in any order. Podium is on. Int n, taken n, and k, sum of the median is maximized. F equals 1, s starts at n plus 1, and the first, second, and third it starts at 2n plus 1. Starting, or yes, it starts at 2n plus 1. And we don't need this. L equals 3 into n. Vector of integer, our answer is going to be of size 3n, and we will start filling it. For I equals 0, I smaller than n into 3, I plus plus. L equals 3 into n. Okay. It is I, or not just plus plus. Plus equals 3. Increase by 3. So the first one is going to be the smallest, which is f. The second one, we will keep it as the median. I plus 1 equals res equals L minus 1, and it is I plus 2 equals L, and we have to update F and L, and then output I smaller than 3 into n I plus plus. See out size equals space new line I equals size minus 1. Will this work? This will work. This will legit work. Let's see. This will give yep, it will say a wrong answer here, but here, yep, look at this. The biggest element is 5, and here the biggest element is 3, same as this. Here the medians are 2 is one of the median, 3 is one of the median, and 1, 2, 3, 1. Okay, our goal is to maximize. Why are we minimizing the answer? Maximized. Yo, okay. Cool. Yep, yep, yep. So the answer for this 1, 2, 3, 1, we shit, median 4 is the median here, and 8 here. The median is 1 is the smallest, 6 is in the middle. Okay, 6, we add 6. Cool. So here we add 4, which is what we add here, and here median is 8, which is the median here, and here the median is 6, which is the median in this block. Cool. So yeah, this is correct. Now next one is going to be D. D, and probably that was correct. Cool. D. Construct a sequence. Like, yep, we are at D. When you sort the, yes, I messed up. My answer was correct. Construct a sequence A containing n integers such that GCD of the current one and the next one is distinct. GCD, this and is distinct overall. It is guaranteed that at least one such thing exists. A containing n integers, and okay, and they can be any n integers. What is the biggest value of n 10 power 4? GCD is always distinct. Can we achieve a case where we can have GCDs equal to 1, 2, 3, 4, 5, 6 till n? This can be very big, like 10 power 19, that is cool. Skeleton. And I should say here, this one has two solutions, pretty simple, but I couldn't figure out why exactly works. Okay, and there is probably like a pattern of making this that we have to figure out. So 1, 2, 4, but if we go in this way, this we would run out of numbers. 2, GCD here is 2, 1, 2, and if we make it 8 here, we get 2. Yep, we run out of numbers. The biggest number we can have is 10 power 64, and we can get as high as, sorry, not 10 power 64, 2 power 64. So we cannot go till 2 power 1000, 10,000, that is too big. And the numbers can repeat. Yo, shit, but the GCD of this and this is 10. No, it failed. And not 5. Yep, it is 10 and not 5. 5 into 4 and 5 into 6. Not a good combination. I guess it might work. Fourteen is the GCD we get here, and 6, 10, 4, 6. Yep, twice. We got 6 twice. No, this won't work. Yeah, I was thinking just that. It won't work. Hello, just be him. Okay, we can find prime numbers and then just multiply them with each other. 10 to the power 4 prime numbers, easy to do. We can use Sieve's algorithm to find them. Shit. Wait, we don't have to actually write this because we have Vim. Yo, I had created this thing, range what? Yes, range is 10 power 4 plus constant. Yep, I had predefined this as part of the boilerplate, so we can just use this. This is not cheating. This is like how pro people write code. Okay, is prime dot set, but I do have to revise this. Like what happened is prime dot set. We are calling is prime dot set to set everything to 0 in this. Smallest prime factor vector. Yep. Nope. 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 We start from 2 primes. Yep, that is the only thing that we need. Primes. We don't need this. We don't need this. We don't need this. We just need primes. And hopefully this will fill. Equals 0, I smaller than n, I plus plus. See out number is going to be primes I multiplied by primes I plus 1. Space or new line depending on I equal plus or minus 1. Yep, should that work? That should work because there legit is no overlap. That is why they are called prime. Or yep, it did take a bit of time. Yep, it is cool. Cool. Wait, we are getting 615.35. 6 is 2 into 3. That's cool. So, yep. This is 5 into 3 and 5 into 7. I think that would work. It's correct, but there is also one more solution. When you multiply two consecutive odd numbers, this and this, then this, but why does this work? For even number, it does not. Where we multiply two consecutive odd numbers instead of even numbers. Shit, it just works if we remove. How many primes are there? Huh? No. There are supposed to be like n divided by log n number of primes. in this range. In 1e6, 78,000, that is still not enough. 10 power 4, no, 78,000 is 10 power 4. Okay, so there is something wrong with our approach. With this, and 78,000. Cool. We are getting all the primes now, and wait, we should not get our stupid error now. I guess I did that in the boilerplate to save time, but that got us the wrong answer. So shit, unfortunate. 26 minutes to solve this is crazy. One test case, 1,000, 10,000 maximum. Cool. No overflow, but if we make this into integer again, one test case, one. Now we do get overflow. One test case. This is very unfortunate. Wrong answers in division 4. Good. Next problem after D is E. You are given an array A initially containing n non-negative integers. You perform the following operation exactly n minus 1 times. Okay, select an index I. Okay, where AI denotes the current length. Okay, let x equal to that thing and set a j some other random number equal to 0 and remove ai from the array. This can be shown that after n minus 1 operations exactly 1 has to determine the maximum possible value. This does not even make sense. Like, what is there to optimize? I think the answer would, the order would not even matter. N is 0, int reference x and a, and this is 0 for int I equals 0. We don't even need to store this, by the way, just saying. I smaller than n, I plus plus. C this XOR C out this. How can we get wrong answer? I don't think the order matters. For all, not just one, for all. For all is crazy. Okay. Vector A n 0 for all. This would depend on which elements we want in our final array and on the parity of the array. Hello, problem number E. And yep, E. Then 3 more to go. Share 1000 people have done this. 800 people have done this one. Okay. Wait, I guess the standing must be very low because I expect that it is not too low, but I do not expect high standing in Division 4 because a lot of people do questionable things in lower rated contests like cloud, chat GPT, group. Yep, these are the questionable practices they do. Okay, take an x. Yep. For 1, 2, 3. Final. We have 3 numbers here. And in the end, we will only have 1 out of them. Yep. Size 3 divided by 2 lower limit is 1. Okay, that is the final amount of numbers we can choose out of this, and that would be 3. We want to remove 2 and 1. So whenever, yep, we want to remove 2 and 1, what do we have to output? We have to output the final best answer. And okay, we can go n square. We can go n square. At max, n is going to be a very specific number. That is very crazy. N is at max 3105. If we divide that by 2, 1552 is the maximum number of choice that we can get, and we can go into binary Shit, yep. There was a problem. There was a very similar problem. Bro, I wanted to go to college today, but uh, shit. Now you can go, like, maybe, but probably wouldn't. And you can count the frequency of occurrence of each bit. Yep, we can. No. Yes, we will have to do bit by bit. Shit, that is a crazy spike. We have to go bit by bit, but the thing is here for something like 1, 2, 3. My claim is that when the size of the array is odd, then the operation that you do is take one element and take its XOR with the remaining elements. And if the current frequency is 0, then the remaining elements are going to be even. So you will be taking XOR of this thing even number of times. And when you take XOR of an element even number of times, you get 0. So essentially, you will not get this element. So whenever the size of the array is odd, you are not going to get that element in your final analysis or whatever. So you would like to choose the elements that you do not want in the final array. And yep, so n by 2 divided by 2, this is the number of times when the length of your array is going to be even. And so which means this is the number of elements you will finally have in your array that you can take XOR of, and you will be cool. So for when the length is 3, 3 divided by 2 is 1 lower limit. You will only have one element out of these 3, which you can, like, 3 is the best one, is the biggest one, so we go with 3. And let's simulate. Let's say we choose 1 here, and XOR of 1 and 2 is going to be 3, XOR of 1 and 3 is going to be 2. Cool. And then you choose this, then you choose this 3, which was 3. Then, so because you want, now the length is even, now you choose the element that you wanted, and that is 3, because cool, yes. Which now is 2. So XOR of 3 and 2 is 1. Shit. You strangely are left with the one that you wanted to go away with. Okay, my analysis was wrong. My bad. But how are we left with 1, 0, 1, 1, 0, 1, 1? If we choose this now, we are taking XOR with 1, and we will get 1, 1, 1, 0. If we take XOR of 3 and 2, we get 0, 1. We will do the operation 2 times, which means we will remove 2 elements, and out of these we will do the operation in total n minus 1 times, which means the number of elements that we can have or we will have, and at the end would be, or the number of elements that we will remove or have would be shade. Yep, it would be n by 2 plus 1. This would be you have n elements, you're doing the operation n minus 1 number of times, and half of these elements will be when the size is odd. Half of these operations would be when the size is odd. When the size is odd, we can just essentially think of that element as gone. And if you are doing a thing 5 number of times, 1 2 3 4 5, only 2 out of 5 are even, so those are the things that you will have, and there would be one extra element on which you never called the operation on. Cool, cool. So in the end you will be left with n minus 1 divided by 2 plus 1 elements. So when this was 3, 2 divided by 3 divided 3 minus 1 divided by 2 plus 1, that gives us 2. So we will be left with 2 elements and not 1. And when we are left with 2 elements out of these 3, 0 1 1 0 1 1, we would like those 2 elements to be these 2 elements. Yep, because their XOR is 3. So first we will take XOR with 3 because that is what we want to. Yep, because that is what we want to give away. We'll take XOR with 3 and we will remain with 1 0 1. If we take XOR with 3, we will have 2 and 1, and then we can just do like any element here, does not matter. It will be the one that and answer will be 3. Cool, 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 cool. There can be mistakes. There, like, of course, are mistakes. Wait, what? Nope. I do not go to college. I mean, I have taken admission, but I don't attend classes. You take XOR of 2 elements with the same element, then take it again. Would it be same as if XOR never happened? If you take XOR of an element even number of times, then it would be that the XOR never happened. And if you take XOR of an element odd number of times, it would be as if you took the XOR only once. If we take XOR of x with itself, let's say 3 times, this is our denotation for that, then this is similar to taking XOR of x with some element just once. So y XOR x, XOR x, XOR x, these two are same. You can eliminate these two. Okay, I'm just thinking about maybe we will, out of n, since we are doing n minus 1 number of times the operation, we will always have one element left. If we just know how many elements we are left with, at the end we would like to find out an approach, a subset, a set of elements which give us the highest XOR. Yes, it is like, yep, yep. So we always will have one element left, and we are doing n minus 1 number of operations, and at max n minus 1 by 2 lower limit. This is the maximum number of even numbers there can be in n minus 1 numbers. If if n is 1, then there is no even number. If n is 2, then there is a single even number, 1 2 2. And if n equals 3, if you call this x, if x equals 3, we have 3 numbers, 1 2 3, then there is one even number. And if x is 4 1 2 3 4, there are 2 even numbers. Pretty cool. Okay, so we know now that at the end we will have n minus 1 divided by 2 lower limit plus 1 even numbers, or you could say we are taking n by 2 upper limit. Yes, these two are equivalent. N minus 1 divided by 2 lower limit plus 1 equals n divided by 2 upper limit. How are these two equal? Because for lower limit you can write n minus 1 divided by 2 plus 1 equals, for upper limit you can write n plus 1 divided by 2. We have to just prove that these two are equal, and n minus 2 divided by 2 plus 1 equals n plus 1 divided by 2, and n by 2 minus 1 plus 1 equals n plus 1 divided by 2. Cut these, n by 2 equals n plus 1 divided by 2, and this is true in case of C++. When we take, yeah, this is true in C++. 2 divided by 2 equals 3 divided by 2. We by default take the upper limit. Cool. So remaining number of elements is going to be n plus 1 divided by 2. And now when we know how many numbers are going to remain, we have to figure out which numbers are those are going to be. Did you feel EP? How? So if like do n minus 1 operations, you will have 2 elements left. No, because in one operation you are removing one element, and you have total n elements, and you removed n minus 1. Out of those n elements, you are left with one element. You give gate? No, I did not give gate. Okay, okay, okay. Now we have to go to binary, I think, probably, to find out which subsets are best. We can now reduce the problem. Let's say all the numbers a1, a2, a3 dot dot dot, we can write them in their whatever binary representation is, and at a time we will start from the highest value bit at bit number 31, when the lowest value is bit number 0. So we will just look at this, and if we flip this like 0 1 0, if we flip this on its side 0 1 0, we will have something like this: list of 0 and 1s, and our problem would be we want to find a subset of size rem, a subset of size rem, subset like in any way or order where the number of ones is odd, which is very easy. No, 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 no. No, not very. It is easy to find a subset where the number of ones is odd. We can just choose out of these the first rem numbers, and if the number of ones in this sub array of size rem is odd, then cool. But if it is not odd, then either have an extra one and remove a zero among from these, or remove a 1 and have a 0 which is outside of these. And if it is not possible, if either all of them are 0 or 1, in that case, no, we cannot have a subset of size rem where the count of ones is odd. Cool. This is a cool problem. 10 watching. Shit. Crazy. This is a cool problem. This is a cool problem. And we can go n square if we want. We can go n square if we want. We can go n square if we want. Not just n square, we can go n square log n. Shit, not just that, we can go if we want n into n, this is multiply, into log n square. Yep, log n square, which is like 2n. Easy. We can do a lot. And I feel like going bit by bit. Might fail because because mm, yep, going bit by bit might fail because let's say you are at bit number 31, which is the highest value bit and has the most priority, and from here you choose a subset, say this and this, which is giving you 1 here, like the number of ones in this subset is odd, and then you move on to some lower value bit, let's say bit number 5, and here you just have 1 0 0 0. Now here if you want an odd number of ones, you must choose this bit, but you cannot choose this bit because this is not the bit that you chose here. So yep, these are like already gone, you cannot choose these. So either you must have the knowledge that this other bit is also a possibility that you could have chosen, Is this dynamic programming? The order does not matter. So shit. Maybe we can just brute force. We have n things in total, and we want to choose n by 2. What is the formula? I guess n factorial divided by n. Okay, factorial is very big. No. N divided by n by 2 factorial square. So you would have n into n minus 1 dot 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 till n by 2 factorial divided by n by 2 factorial for the highest value of n. Let's say highest value of n is 3000. So yep, divided by 1500 factorial square and 1500 factorial cut and 3000 combination calculator. Let's calculate, because this is a lot of manual multiplication and we should not do this. We have in total 3000 things and we want to calculate 5000. Okay, that we cannot brute force. This number has like 901 digits. We cannot brute force. Brute force is not a possibility. Wanna be hacker? Hello, Vyad bhai. Shit, drink some coffee. Andhra Karpati said coding jobs aren't going anywhere, and he's the one making AI. Loki, this think, does this problem need DP? Shit. This might need DP. Okay, we do know that the total number of possibilities is very big, like 10 power 900 big. Using DP, we can reduce the search space. That is like, we will not go through all the possible test cases, but only the ones that we need to go through, because a lot of these are going to be obviously wrong. No shit, nope, nope. We cannot use DP here also, because even if we do go bit by bit, the number of bits that we will have at a specific place is still n, and n can be 3000, in which case the total number of possibilities are going to be 10 power 900 big. So to just summarize, what we are after is, we have n numbers, an array of n numbers, and out of these we have to choose n plus 1 divided by 2 numbers, lower limit, whose XOR is as big as it can be. Just that. Out of n, we need to choose n plus 1 divided by 2 numbers, such that their XOR is as big as it can be. This seems like a standard problem, like there should be a specific solution for this one, like classic problem. And the obvious approach is, like kind of obvious, is if we divide those numbers a1 a2 dot dot dot, write them in their binary representation, whatever it is, let's say this is the highest bit number 31, bit number 0. We would like to make the selection such that we want a up bit, one bit here in the highest position. We do not care about all the rest of the ones. First, we want a one bit at the highest position, the highest place value. If we can secure that, then only we will move out to the rest. And we can go any square, we can go any square. Okay, let's look at the next problem. Maybe we can do that. We'll see. Shit. Hey, hello. Yep, they are memeing their way. G, lol. Wait, what? I'm preparing for the I find PNC and binomial hard, and these topics are deeply in programming. Not deeply, not deeply. No, these are not deeply in programming. You will occasionally find them, and even here, what I did was just apply the formula of combination, and like it is the least thing you can do in combination and permutation, just like know the formula. So yeah, these are not too deeply in programming. Shit, okay, Ruby on Rails, that would be cool. Make your own thing. Okay, let's see this one. Tree problem. Trees are better. You're given two integers x and y. Your task is to construct a tree with x plus y nodes, rooted at node 1 such that exactly x nodes in the tree have even subtree size and y nodes have odd subtree size. If multiple value trees exist, output one of them. And we have to output the edges. And this is a tree. We get two numbers x and y such that their sum is smaller than 10 power 5. Okay, this should not be too difficult. Say this one, 4 and 7. 4, even, odd. If we have 4 and 7, we want 4 subtrees to have even. Okay, and okay. Root node is always going to be 1, and in total there are 11 nodes in this. 4 plus 7, 11, and the subtree size of 1 is going to be 10 because that is the rest of the nodes. We can like use up one of these. 4, 1, 2, 3, 4, 5, 6, 7. Okay, so we will say out of 4 even subtree nodes that we wanted, this root node is one of those. Okay, we just need 3 more, and here we need 7 more. Okay, now let's say we want odd subtree node now. Let's say 2 is going to be odd because it will have the rest of the elements. No. If we can make it that x equals y, let's try to solve this for x equals y, or when the difference is not more. Let's solve this for x equals y. Let's say x equals 5 and y also equals 5. Then I think we can just make a straight line, 1 connected to 2, connected to 3, connected to 4, dot dot dot, till 9 is connected to 10, and here 1 has a subtree size of 9. Cool. So odd nodes come here, even ones come here. 1 is going to have a subtree size of 9, odd. 2 is going to have a subtree size of 8. So 2 comes here, and then 3 will have odd, 4 will have even, 5 odd, 6 even, 7 odd, 8 even, 9 odd, 10 even. Cool. 5, 5. Cool. So when these two are equal, we can just put them in a single line. Very cool. But when these are not equal, let's say x is 6 and y is 5. When x is 6, y is 5. And there are two conditions. When x is bigger and the total sum of these is odd, in this case, which it is 11, then the root node, here we began with one which was even, one which had a subtree size of odd. In this case, we will begin with a node whose subtree size is even. One will have 10 nodes under it, so the subtree size is 1. So instead of beginning with even with odd, we are here beginning with a node whose subtree size is odd, and then we will just keep alternating odd, even, and at the end we will be at 11, and that will also be an even node, and in this case it is just solved. Cool. But if that was not the case, let's say x was equal to 7 and y was equal to 5. Here the root node is going to be of the other type, the thing that is smaller, which is y. Okay, so this is going to have a subtree size of even, because the total sum is 12. Odd, total sum is 12. This will have under this 11 nodes, so yep, subtree size of 1 is going to be 11, which is odd. So we have 4 nodes remaining whose subtree size must be odd, and 7 nodes remaining whose subtree size must be even. Cool. So we need to use up 3 more. If we do this, 2, 3, 4. Straight, we can like legit do this. Even. Okay. 1 will have a subtree size of 10. 11. 1 will have a subtree size of 11. And then 2 will have, if we just put all the rest of the nodes as children of 2, this would have a subtree size of 10. But if we use out of those 10 2 nodes here, then 2 will have a subtree size of 8, which is still even, but we have increased the number of even nodes by 2 here. And now we can just do 5, 6, 7, 8 till 11 is connected to 12. Here if we count, 1 has a subtree size odd, this is even, and even, then odd, even. In this whole list, there are 9 things where we begin with even, and when the size is odd, we end with the same thing that we started with. So in this whole list, the number of nodes that have a subtree size of even is 5, and the nodes which have a subtree size of odd are 4, and we had one odd node here. So 4 plus 1, in total we have 5 odd nodes, and 5 out of this, and 2, 5 plus 2, 7 here, which is what we wanted. So we are making progress. Yo, a progress on the thing I was doing. I was somehow able to get a CAGR 89%. Wait, what is CAGR? Sharpie ratio. Hello. 3 and 4 will have odd. 3 and 4 will have odd sizes. Do we include the root node? One. Yes, it is possible. Subtree is a set of all the vertices that pass through you on a single path to meet the root, including you itself. Shit. Okay, you are correct. You are correct. They would be even. My bad. Compound annual growth rate. Shit. Okay, you can go and sleep then. Need to see which platform should I start with, LeetCode or Codeforces. Both are so good. Just pick one, either Codeforces or LeetCode. I would say start with Codeforces and just stick to it. Do not try and figure out which one is best. Just stick with Codeforces and move forward. Just make progress. If you get good at Codeforces, you will get good at LeetCode and everything else also. And yep, you are correct. Shit. 3 and 4 will be odd sizes because we include the node itself. So for x equals 7 and y equals 5, this is odd, this is even. When odd is lower, can we even solve this when number of odd nodes and lower is lower than the even number of nodes? Shit, I think we cannot solve this when even is greater than odd. Let's see. For x equal y, there is a solution. Cool. Let's say if x equals 3 and y equals 2, can we solve this now? Here, with the new added information that the root node is also going to be included in the subtree size. 5, this is odd. Okay, so we have already used up one of our odd nodes. We have just one odd node remaining and 3 even nodes that we must add, which means there can only be one leaf node. Whatever it is going to be, that leaf node is also going to be odd, so we cannot have more than one leaf nodes. Cool. And yep, so one root and one leaf node means everything is in a single line. So shit, but yep, 1 2 3 4. We have already failed. Yep. This is not possible. Here the answer would be 0. Answer would be 0. Yep. So the number of even nodes, which is x, must be either equal to or smaller than the number of odd nodes. Must be is a crazy word. We have to prove it. Let's say whenever we have a leaf node that is odd, a leaf node is always odd. Cool. Let's say we have put all the nodes in a single line, right? Okay, and the size of this line is n, and out of this n, half are going to be odd and half are going to be even. If n is 4, we begin with even and we will end with odd. And if n is 5, we begin with odd and end with odd. We always end with odd. So out of n, n by 2 lower limit is going to be the highest value of x I think we can have. Yep, that is the highest value of x that we can have. We cannot have a x that is higher than this. And y, I think this is the minimum number of y that we can have, n by 2. Yep, because if we want to increase the number of odd nodes, then we can just remove this last one and put it here. Now the parity for this one is the same as it was before, but for this one, for or let's say here, if this was ending at no, if n, let's take an actual example, 1 2 3 4 and 5, we have y equals 3 and x equals 2. This is this and this. Yep, these two are the only even subtree nodes. Cool. And if we remove this from here and we put it here, now this is still odd. These have switched. Now this is an even node. So x is now 1 and y is now 4. We have a new y. Shit, we just yep, we don't even have to care about what happened here, because we know for a fact that the number of y increased by 1 because we added a new node, a new leaf node here. And if the number of y increased by 1, x automatically got decreased by 1. And can we increase y by 2 at a single time? I don't think so. Cool. So yep, cool. This is very doable. And I hope we have time. We have a lot of time. Let's go. X, y, taken x and y. We have x and y, and if x greater than y, see out, nope. And return else. I equals 1 and for int I equals let's say currently the node is 1, and it will be connected to its next node. We need how many extra y's do we need? Say int extra y is going to be the current y that we can have, which is n plus 1 divided by 2, which is x plus y. This is the number of y's that we have right now, and we need y in total. So this many extra nodes we have to add. For int I equals 0, I smaller than extra I plus plus. See out, make a connection between C and C with the space, with a space. Shit, printf is not here. printf digit space digit comma, the first digit is C, second is also C. Unsequence modification and access to C. And next. Printf no with a new line. Shit, yep. Before this, we have to say yes. C equals C plus 2. No, shit. No. Wait. I'll be right back. I have to go to washroom. Yep. Right back. Cool. I'm back and yo. Wait. Yes, this is crazy. Line 18. Nope. Yes. This is not right here. We don't have to output this. We can. Yes, we don't even have to use printf. We can make do with not printf. Yes, line. Okay, and we need none of this. We just need to output 1 has a connection with I plus 2. With I plus 2, yes. Yes. And then we will have another loop int I equals 0. I is smaller than x I plus plus, or we can, the next node would be rem plus 2. Extra ex plus 1, and so we were going from 0 to x. Now we are going from ex plus 1 to x plus ex plus 1. We just shifted the whole range. The size is same. Can we have x equal to 0 ever? I guess we can if x plus y is odd. I think we can have x equal to 0 in that case, but if x plus y is even, then we cannot have x equal to 0. Yep. So let's check for that also. If this or x plus y is not equal to 0, that is equals 0 if x plus y equals 0. I guess parity. That is, this is odd, this is even, the sum is even, and not x is also 0. In that case, there is no answer possible. Otherwise, answer is always possible. We begin with x plus 1. If x see out, make a connection between 1 and now, yep, now we will have to do unholy things, like you were saying, bad stuff. Shit, this exactly. I has a connection with I plus 1 with a new line. Let's see. Yep, this will say wrong answer because we have our own way, and shit. Wait, we said no. Yes, because we have to give like yes, and 1 is connected to 1. Amazing. Extra need is 0. We don't need anything extra. If x equals y, then we should begin with plus 2. Yes, plus 2, plus 2, plus 2. Plus 2 makes sense. Let's see. Yes, yes. How are we outputting less edges than there should be? 1, 2, and 1 is connected to 3. In this case, 2 and 1. It shouldn't the answer be 0? Answer be no? Yes, it is no. It is this that we are getting wrong. X equals 0. If x equals 0, 3, it is possible, yes. 1 is connected to 2, and okay, we do also have extra, yes. I is connected to C. Cool. I was expecting to see one here. Okay, cool. That is very cool. All of the rest are same, but here we have a different answer. One connected to 2, 1 to 3. One has two child, 1 and 2 and 3, which does not seem right. One connected to 2 and 3, 4 dot. Initially we had 4 plus 7, 11 things, and out of 11 by 2 upper limit, 6 of these. Yes, cool. Okay, shit. Correct. We are getting the right answer. We just needed one extra node at the side. 1, 3, 1, 2. Cool. Okay, we will submit this now, and hopefully this is right. Like, no problem with this. Code forces. Fastest website. Shit, 5,000 people have done that one. E. Combinatorics is difficult. F tree problem. Maybe we should have tested this a little bit more, because we still have like 41 minutes. We could have thought a little bit more about this and then submitted, but yep, we should have. we cannot increase the number of even nodes, so this check is correct. If x is greater than y, then shit. Or if x is 0, when x plus y is odd, and when x plus y is even, then also not possible, false. Then we begin with c equals something. Shit, maybe we messed up here. The default c should be 2, and if there are some extra things, then we do this. Shit, that might actually be it. That might actually have been it. Let's test this. For example, now we do start with c equals 2 by default. We have one test case where x equals 3, y equals 3, and we see shit. Okay, we should begin with 1. Yeah. Compile. One test case, 3 and 3. Cool. 1 to 2, 2, 3, 3, 4, 5, 4, 5, 5, 6. But this should also have worked. Like, shouldn't be any problem. Compile. One test case, 3, 3, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6. Cool. Yep. And this is what we submitted. C begins at 1, and we do C++ at the end. Right? That is what we submitted. Yo. The problem does not seem to be in this part where we are figuring out whether a solution is possible or not. The other part also seems like all right. No problem with this. First we increase, we get how many extra nodes we need. Yes, The logic is right. The logic seems to be right. The logic is right, but we might be messing up in some other case. What do we mean by C? C means the next node that we begin with. Might be this which is messing us up. One is at the root. Next is going to be 2. Yep, and we begin with 2. So we don't even have to use I. We can just use C. One two one two is crazy. Why didn't this increase? Shit, because yes, of course, shit. Cool. Correct answer. We are getting the correct answer. Let's see. Let's see if this works. If this does work, that would be cool. There are no junior roles in machine learning. I will be happy if this works. And it doesn't. Shit. But what part of this whole thing could be wrong? Everything seems okay. What if both of them are 0? Shit. If x equals 0, and can they be 0? They can be 0. Both of them can be 0. Shit, we have not accounted for that case. If they are both of them 0, then we do this. Shit. Okay, yep, makes sense. They could both be 0. No, shit, we would in that case output no, which is wrong. And y is something. Okay, yes. Okay, I guess that was the problem. Here, just one test case. If both are 0, then answer is yes, and we are connecting nodes 1 and 2. Shit. Wait, if answer is and if not x and not y, then both of them are 0, then answer is yes, and return. One test case, both are 0. We just say yes, and we are happy. Cool. But if we remove this, which possibly was the mistake, we would say no. 1 0 0 no. Yes. Okay, so that was the mistake. And y exit. So the cases when the answer is not possible is when x is greater than y, or when x is 0 and y is not 0, and the total number of nodes is even. Yep, those are the cases when the answer is not possible. Compile 0 0. Cool. Empty tree also satisfies. Shit, probably that was the mistake. We'll have to see. If this also goes wrong, that would be crazy. Would you rather have a mind where you have to answer every single question, but you don't understand the things that you wouldn't have immediately understood otherwise? I'll receive a call. Okay, you can have a nice chat then. Would you rather have a mind where you have the answer to every single question, but you don't understand the things that you wouldn't have immediately understood otherwise? Wait, when you have the answer, I don't think we can have the answer to every possible question. That wouldn't that make you omniscient? Wouldn't that make you omniscient, and therefore you would know everything before it happens, and therefore everything would be deterministic and like shit. Okay, still no answer, still no answer, still shit. I cannot figure out what is wrong with this. The logic seems flawless. Like Max Verstappen type flawless. But we just don't get the right answer. Let's try this one, the last one. Okay, 6. Okay, the whole theme of this thing is 6767. Counting is fun. Let's see how fun it is. 24 minutes. Maybe we might be able to solve this. Okay. You are 12:30. You are given two integers and m and an array b of length n, where every number is smaller than equal to is smaller than m. It is guaranteed that every integer from 0 to m minus 1 appears in b at least once. So n has to be greater than m or equal to m. Equal to m would also work. Yep. A group of n people are standing in a line in fixed positions numbered from 1 to n. They all want to sit down, but some of them are too socially awkward to do so immediately. Ryan Gosling, for some arbitrary array of length a and fixed number of positions, there are n people. Okay, array of length a, where every number is from 1 to n. Each person I has a social awkwardness level. Yes. Consider the seating process, which evolves in discrete units of time as follows. If ai equals 0, person I will sit down at time 0. Okay. Okay. Person I will only sit if ai is 0. Person I, okay, all of them are already there. But if non-zero, person I will sit down at the beginning of the time of a time unit t. If both of these things are true, at least ai people have already sat down strictly before time t. At least one of the neighbors, if they exist, has already sat down strictly before time t. Neighbors. Okay, why do we even need b array? At the beginning of each time unit of time, each standing person checks these conditions. All people for whom the conditions are satisfied sit down simultaneously, and then the process advances. Okay, for each I, the value bi denotes the time unit at which person I sits down. Your task is to determine how many distinct arrays a are consistent. Shit, since this number can be very shit. This is crazy. This is actually crazy. Please note down this problem uses an unusual modulo. This is prime. That is crazy. I would like to add this one to the list, review list. This is a crazy problem. And this one also. We have an array A. Like A makes sense. We can figure out A. But we have been given B, the order in which all the people sat down, and not the array that they used to look whether they should sit down or not. And we need to figure out how many possible A arrays there could be for a given set of B arrays for this current B array. And one thing that we have been given is M, which is M is the highest value in B, and at least all of M appear at least once. Yep. So M is smaller than N. Makes sense. So m is the maximum time unit. M is the maximum time unit. Here answer is 2. There are just 2 things available. So this person sat down. Okay, so the zeros that are here in B will be the same zeros that we will see. Yep, will be the same zero. In all of the A arrays, possible A arrays, zeros would also be in the same positions. Let's use AI. Shit. New normal. These kinds of assignments are now, well, they are not obsolete. It depends on your goal. If your goal is just to like get the solution, just submit the right answer as fast as possible with as little effort as possible, then yep, use AI. But that is not my goal. I want to develop cognitive skills, thinking skills in this. Here, no possible solution. So zeros are fixed in A and also in B. We have this. Our possibilities of A arrays is this. Some random numbers will be here. Now, this person, there were at time 0, let's say time is in this axis. At time 0, this person sat down. Sitting down would be represented by 1 and standing up would be represented by 0. So only these two people were sitting down. At time 1, we see that this person sat down, because that is B. It is telling us what was the time when this is when the ith person sat down. So this person sat down at time 1. So 1 1 0 1. So we went from here to here. We went from here to here, which means two conditions must have been satisfied for this person. And those two conditions are, first of all, one of the neighbors is sitting down. Cool, condition is true. One of the neighbors is sitting down, and the other condition is at least AI people are already sitting down. That, and at least this many. And right now there were, when this person sat down, two people who were already sitting down. So this number could have been 0 1 or 2. That is 3 possibilities. No shit, this could not have been 0, because he would have just sat down. So yes, our possibilities begin from 1 and 2 are the only possibilities that are true here. Cool. Then we see that at time interval 2, this person also sat down. 1 1 1 1. So out of the two conditions, for this person, the condition that one of the neighbors must be sitting down was already true, but this person didn't sit down. Must have been because the number here should be 3, because only then this person sat down. So the total possibilities of A arrays is 0 1. Total possibilities is 2, and those arrays are these A1, and the second possibility is 0 2 3 0. Cool. So I am human. Like if you stab me, I will die. Shit. Because I'm not explaining correctly. The fault is on my part, not on your part. It is I'm not able to explain correctly, or in a way that is understandable. There is a thing, your cognitive skills are now irrelevant. Okay. I don't want to improve my cognitive skills just because Wait, why are they relevant? They are very, very relevant to me. If like uh, if you are like sending this message and I am able to read and understand that, that is because of my cognitive skills, that I can read English and understand English. How is it irrelevant? If I didn't have them, I wouldn't even be able to understand your message. So they are not irrelevant, not to me at least. It doesn't matter how much you improve, even the most inferior model will always be better than you. Okay, fine. Instead of learning this, learning out RAG, I don't know RAG, sending up agent orchestration, those are more important. Yep, I am working on DevOps. Yep, I am learning about DevOps. Oh, cool. Agent orchestration. Right. Agent orchestration is a word which a friend of mine was using, and I'm suspecting you are one of my friends in IRL, and you are kind of trolling me here. Maybe, like, that is just a guess. Okay, cool. So we know this. We can just go time by time. We do have M, the maximum value in B. The maximum value is in B is going to be M. Like legit, it is going to be M. We know B, all of the values in B are smaller than M. So yeah, cool. We can iterate through time from 0 to 1. Okay. And shade, but size of A. How do we see how many people sat down? The time complexity would be too much. We can go through time, like go through time. What was the state of people who were sitting down at time 0, at time 1, at time 2, dot dot dot, till the maximum time, which is M, and M can be 10 power 5. That is full, right? We can have a loop which runs from 0 to 10 power 5. That is pretty cool. But at each loop, at time 1, let's say, we have to go through all of the elements in this, which is wait, shit, we do not have to go through all the elements. We just have to go through all the elements whose state changed from 0 to 1. Just those. So let's say at time some x number of people were sitting down, and at time 1 some x plus y number of people were sitting down, and then at time 2 x plus y from here plus z new people are now sitting down. So if we look at the difference, like how many new people sat down, here it would be y new people sat down, and here it would be z new people sat down. And if we sum these differences, like how many new people are always sitting down, this sum will not be greater than the size of b. In total there are n people. In total there are n people, and if we all just add up all the new people who are sitting down at the end of each time second, the sum is not going to be greater than n, because there are at max n people and we are not counting one person more than once. So we will go through all the people. Cool. Cool. So we this is not going to take up a lot of time. We can easily find this, but we do have to pre cool. Cool. So yeah. And now how do we find out who are the people who sat down at a specific time? If we have, like, if you are at time equals 3, how do we know who are the people who sat down at this time? Or yep, what are the index of those people who sat down at this time? It is just in the B array, like here in the B array, whichever element has value 3, those are the people who sat down at time 3. So makes sense. makes sense. Makes sense. But still, at every time t, we do not want to go through b and find out all the values in b which are equal to t. So what we will do is we can create a map. Okay, let's just start implementing. I don't think so we will be able to do this in 9-11 minutes, but we'll see. We have n, and n is the first thing and m is the second thing. N and m, and then we get b vector, b's size n 0 for int reference x b, and then we will have a map where e is an integer and value is a vector of integers. MP would be the name for int I equals 0, I smaller than n, I plus plus, MP, yes, MP bracket current bi element dot push back the index. Cool. Now our main loop from 0 to m. All of this is pre-processing, getting data, and this making data available in a way that will be more useful to us later on. It makes more sense. The response, let's say initially, is 1, and mod, we have to take mod with 676677, like this number. Okay. So at time t for int x in mp t, all the people who sat down at this time. For 0 we don't care. No, we do care about 0. We do care about 0. Currently the number of people who are sitting down. Yep. C is mp 0 dot size. C is the current number of people sitting down. And since we have already considered time 0, we can just begin from time 1. And x is the index of a person who just sat down. And we want x this person just sat down. This person just sat down. Wait, can we just have mod or res multiply by equal to multiply by c. I think we can. And take its modulus with 1. And then C would increase by MP T dot size. Yeah, I don't think so. This would be this simple. Your okay. M4. But from what I'm hearing, your friend sounds like an intellectual. You should listen. Okay, I will listen to him more. I didn't say all generic cognitive skills are irrelevant. What I meant is these questions prepare you for a certain type of skill, and that skill is, I won't say irrelevant. This like helps me. Getting better at competitive programming has helped me in learning new things. I wouldn't be able to understand these random new things, which I have no idea about if I was not practicing competitive programming on site. Yep, like understanding what is NixOS and all that thing. It has helped me quite a lot. We are getting a wrong answer because shit. How do you know when the answer is not possible? Even when the answer is not possible, we are outputting a wrong answer. Yep, and yeah, my like cognitive skills are not so good. I'm getting wrong answer. Yep, all the best. Makes sense. Makes sense. There also has to be a lower. Yep, we are not considering the lower limit. Yep, C is the highest value that could have been at a specific index, but what could also be the upper limit? Here we took 2 for this, which is correct. And there could have been 2 possible values in a array, but for this, the only possible value here which could have been here was this. Okay, okay, okay. We will have another vector mn, size would be n. Initially all the things would be 1. Yep, and for n equal to 0 I smaller than n I plus plus. If vi is 0, if bi is 0, cool. Yeah, we don't give a shit about this. Yep, if bi is 0 is this. Into if x greater than 0, that is, we can go to left. There is something on the left of x. We'll say mp or minimum value for x minus 1 is c. If x is smaller than n minus 1, we can go to right. Mn x plus 1 equals c, and here do not multiply by c, multiply by c minus minimum of x. Let's see. 0 is crazy. Plus 1. Okay, 2. That is like very good. 2 is very good. Time complexity is correct, no problem with that. But okay, contest is over. We were not able to solve 3 problems. We only did 4. Not a very good performance. And standings. What are the final standings? Wait. Friends, standings and shit. Kakashi. You have gotten good. Hello. Okay, this is very sad. My friend was able to solve like almost all the problems, and I messed up totally. Shit. Okay, but cool. That just means we have to improve. And for today, that would be it for like competitive programming. That would be it. And thank you for being here. We gave a contest and we only solved 4 problems out of 7 in Division 4. Not too good, but that would be it for this. And thank you for being here.